All right. Yes, we are live.
Awesome.
We're live with Barak Arikan, and I'm gonna give an amazing intro for Barak here because we are both New York City dudes, and Barak's background is simultaneously very similar to an artist, a digital artist, and also a developer. So I'm gonna do my best to give him some props and send him on the roof here. So Barak is a New York and Istanbul based artist who works with complex digital networks. So he investigates societal issues and develops his findings into abstract machinery, which generates network maps and algorithmic interfaces, resulting in performances and procreates predictions to render inherent power relationships that are visible and discussable. So this is obviously the artist's statement. Arikan's software, prints, and installations and performances have been featured in numerous exhibitions internationally, including museums like Museum of Modern Art in New York, and Venice Architecture Biennial, Sao Paulo, Istanbul, Berlin, Sharjah, Marrakesh, just to name a couple. Arikan's also the founder of Graph Commons, which is what we're going to be discussing today. He's the co-founder with a gentleman by the name of Engin Erdogan. So yeah, we're happy to have you here to talk about networks, subnets, validators, and this general sort of geometry of the space. So thanks for your time, Barak.
Yeah, thank you. Thanks a lot, Nathan, for inviting me, for everything. It's a pleasure. Yeah, so just the little fix in the information. Engin Erdogan is my collaborator in the Valtz IO project. So Graph Commons is a separate thing, but yeah.
My apologies.
I know it's complicated. It's okay. just to fix it for the record. Yeah, so I want to talk about. I want to start actually with this article that I wrote more than a year ago now, over a year ago. It was published during the Avalanche Summit last year, around March. I'll show you the article here first. Like you can check on Medium. It's a very long article, but it's actually quite good. It's called a comparison of heterogeneous blockchain networks. It's a article that I talk about the promise, of the open decentralized internet, and that the fact that it has been challenged by performance, usability, and energy efficiency problems, as you may all know, of the first generation blockchains like Bitcoin, Ethereum, and others. While the development of Ethereum's new version of and its layer 2 solutions that we know today very well, they aim to remedy these problems, those performance problems. But the new generation projects like Cosmos, Polkadot, and Avalanche, they released their infrastructures, their extraordinary, I think, infrastructures before that, like a year before, maybe, let's say, more or less. So these new projects, that people are familiar with this now, maybe, but I'll just gonna recap that. They aim to scale horizontally with an asynchronous, heterogeneous network model, where application-specific blockchains, can coexist and interoperate with one another.
Yeah, this is great.
Right,
Barak, we had earlier. Chorus One spoke a little bit about this, like the Cosmos app chain thesis yesterday, and this is a super famous article. I remember reading it, and going through these type of architecture differences will be super cool to go through. So, just for our listeners, we're gonna. Go ahead.
Yeah, one thing I want to say about this, like just to emphasize the problem here a bit more, like technical people in general are familiar with that, but more broadly, there's a big challenge. It's the scaling of the blockchain. The number of users per day, active users, is very low. If you're aware of this, like 500,000 on Ethereum, the entire Ethereum network. It's an average per day. Whereas on Twitter, for instance, it's 200 million. Whereas in Meta or Facebook, the whole WhatsApps and stuff, everything, 2 billion people per day. This is a giant number. And how to go to that scale? obviously has a lot of issues. So one thing, I mean, there are a couple of categories to consider in that, and like energy efficiency is kind of solved, but computational throughput is a very complex problem, transaction latency, so on and so forth. And the levels of centralizations are also very important. But one thing that to go through into detail, like as you may know, the difference between Ethereum's new version and the Cosmos Polkadot Avalanche, I kind of combine them, but obviously there will be differences. I'll come to that point. Is that the fast transactions is enabled through performance isolation, as you may know. So separate chains, they have their own world, own virtual machines. They maybe a game, maybe whatever, a separate app, and yet they can somehow talk to one another when it's needed. But at the same time, they run on their own virtual machines with different validators behind them. So that kind of creates this performance isolation and obviously fast transactions and so on. One important detail, like to focus a bit more technically, is that any blockchain is more or less composed of these core components, like a database, a P2P network, a consensus mechanism, a transaction queue mechanism, and then a state transition function, like a virtual machine, basically, that kind of enables that, right? And Cosmos again has Tendermint, Polkadot has Substrate, and Avalanche has now finally Hypers SDK, which I'm really looking forward to try. I haven't tried it yet, but yeah. So the thing is, this will take us to this interesting level. So
great. This is the sort of seminal image that has made its way through the meme.
Yeah, exactly. This was like something I draw, I think, to really explain to myself, but also to the broader public that what are the differences between these like heterogeneous blockchains, multi-chains, let's say. Cosmos, these black lines to clear are bridges. I know it's visible here. I can maybe just try to
right. That's IBC, right?
Yeah, exactly.
That's the IBC relayers.
Relayers, they I think it's basic the light client implementation of each other.
That's right. So that's where we are. That's what we built. So our next 4 months is building the light client for Avalanche for that zone.
Yeah, the Cosmos or light client within Avalanche and run through a subnet, right? That's
right. So like the piece that we would add to this image is the landslide little bar, the little black bar that represents Avalanche talking to Cosmos, right?
Totally. Yeah, exactly. You can have a line like that.
Yeah, that's right.
Through those. That's amazing, actually. In the Cosmos world, for those who may not be familiar, they're like these, when you run a chain, you have your own validator network, basically, and in that chain, there's, the activities takes place. And if you want to connect to other, you use IBC. In the Polkadot, they have the shared security mechanism. And so, for instance, what they call a parachain, it has maybe one or more, validators in them. It's called collators. They basically, send transactions and receive back from the relay chain all the time. And this way, they kind of run with a single machine an entire blockchain network that's kind of tied to or inherits, let's say, its security from the Polkadot main chain. Different structure. You don't have a validator there yet, but you can have it actually. It's not actually limited or hard-coded into the protocol. It's possible, and also it's possible to have chains between those parachains without the relay chain itself, and that's another architecture they have, but it's not really commonly narrated or used at all, but they exist in the architecture. Avalanche obviously has a very different topology for interchain economic security, which is overlapping networks, right? In this case, these subnets share validators between them, and with this Valtz IO project, we're trying to kind of show that a little bit more and then see how it's going, basically, to kind of monitor this network growth in a way. I'll come to that a bit more later, but one thing we can look at here, so in Valtz, basically,
yeah, this is gorgeous. This is super cool. This is why I reached out to you like early on, because I think Valtz was the only graphical representation of the network in any really meaningful capacity. So this is cool. So I encourage people listening on places where they don't see it to go on and check it out.
Yeah, our goal with this project was to really, highlight this vision, the shared validator. It's like a group forming network in a way, like these different groups, subnets as groups are kind of forming as validators shared between them. And it's a long road, definitely. It's not going to be easy, but it's happening. As we know, main chain, there are more than, I think, 30 subnets now. On the Fuji network, test network, there are hundreds, literally. I'll come to those. But the subnet basically, sorry, the Valtz IO is basically what you see here right now. It's an interactive diagram with a dashboard. Like you can see the up-to-date data, like the the counts, validator counts per subnet in a list. I mean, you can see them in some explorers too. By the way, it's nothing magical. But at the same time, here our goal is to really focus on this the network structure itself, and I kind of focus on especially metrics like stake per cap, like market cap of the chain versus how much is stake on that. It's an important ratio to follow as a security metric for any given subnet or blockchain. So because there's this discussion how much validator I need for my subnet. It's unknown information at the moment, but it's been said in many times by the Avalanche team, for instance, that if you're a game, maybe 30 is okay, but if you're more like institutional network or something like with institutional finance network, maybe you need more hundreds or something. So, but still, there's no clear number about that. It will emerge over time, obviously.
Right.
So we are trying to track that, how it will emerge, and on the way we can see things, and we can maybe monitor it and discuss it more broadly in the community. I will open this to this graph in a larger version, so we can see it clearly, and I can dive into it a bit more. And this is like an interactive graph. You can zoom in everywhere. And here, as you know, just as an example, I'll open this little list here too. This is the list of subnets in this current mainnet by the number of nodes, validators in the subnet. So for instance, this is one subnet running Dexalot EVM as an example. It runs those 11 subnets or 10 nodes run this subnet, which runs Dexalot EVM. And at the same time, of course, again, just to remind, all these nodes are connected back to this main chain down here, which is basically the primary subnet, which is running the C chain, P chain, X chain. And if you zoom out again, you see all these chains getting their nodes who are also running the blockchain, and there's huge potential. Like all this large circle around it is basically the validators who might be joining those subnets in the future, and it will grow over time. One way of looking at that is to look at the Fuji, actually, that feature.
Yeah, man. That's what I'm talking about, man. That's the slime mold right there.
Yeah. So in the Fuji, what happens is see the difference? Like there's the center and again the same network, but the main network, and then there are all these different little guys, running different spaces. As an example, the famous subnet project for it's a good experiment, and it's run by maybe the Avalanche team and some others, but it has 19 validators.
Yeah, it's like a sort of decentralized file storage.
Yeah, right, exactly. And then there are very interesting patterns in this. If you zoom in this, you can see, for instance, some subnet has these two validators, but there's
so this is Swimmer. So this is the Krabata subnet.
Yeah, exactly. I'll click multiple of them with my command and click. You can do the same if you want. You can go into these links. See that there are these patterns emerging, one after another, these guys and running the same networks or different networks. And Kyra, or I don't know what that blockchain is, but Kyra shares nodes with Swimmer at some point, or in one more step, maybe. So indirectly, let's say, and they share. And also, if you look at some subnets like this, some nodes which run many different subnets at once. What is that? I don't know, but that's interesting. And then this seems like it's called Prospero, maybe a game engine. I don't know what it is, but they have all these experiments. And then there are many examples of those like these big flowers, let's say, open up, and there's single nodes running many different subnets and different chains on them. Maybe it's just, I guess, maybe doing tests, on those. And obviously, it's beyond subnet as a testnet, so they are doing tests probably. And people do tests, for instance, by combining, two nodes, for instance, and multiple subnets. Interesting topologies emerge there. DOS testnet. Again, I don't know what it is, but you can see the topological experiments they do. Yeah, and then so one thing.
One question I have is, do you want to bring up how this relates to like map of zones on Cosmos so people can see what that looks like?
Yeah. So
or maybe how does this compare to like the heterogeneous topology on Polkadot?
Cool. Yeah, in Polkadot we don't see this. It's probably, I don't have a map of it, but basically it's from single location. There are going to be different chains around it, basically. I mean, it looks similar, but you see the Fuji, even though it has a super central, obviously, subnet in the center, it is starting to interconnect, on the leaves at the moment. And I think this will grow this way. This will be more like a network that's interconnected on the leaves. Like, I'll switch to another view of which is Cosmos.
Yeah, great.
And this is for the first time we're just showing this work, by the way. The Cosmos
great.
Work. This data is from October, by the way, 2020. So it's not super fresh, but we're working on this to make it up to date. There are problems in the Cosmos world. There's no name system for the validators. It's hard to make them unique and kind of find those matches, as opposed to Avalanche, which is, as you know, there are IDs for every blockchain, every subnet, which is amazing.
Yeah.
And here, so in this world, but there are interesting patterns in the Cosmos, because this is more maybe like a live system. You're looking at a very large, let's look at the numbers too, very large network. Like there are 47 blockchains here, the red dots, and 1,500 validators in total. Even though they run their own chains, but some validators are in multiple chains, right? And actually, many validators are in multiple chains. As an example, like say Binance validator running Iris, Chinese, I think, project, as I remember, and then Band. I don't know what it is, but they're both worlds. Or Crypto Lion in 3 projects,
so this doesn't show the this. I don't think their interchain security at the time was kind of accepted yet, right?
Oh yeah. Oh, the thing is, this is not a map of zones type of. Oh yes, I guess this is what you mean. It doesn't show the IBC connection between them. It just shows which entities run which chains. Okay, so it's important as a security metric. If
understood.
It shows. Yeah, it doesn't show the communication between them at the moment, and there are good projects like Map of Zones. I think it's one of them. Yeah, there you go. Map of Zones has this very nice.
Let's just bring that up so people can see. Yeah, this is cool.
Yeah, exactly, and it's loading. But here you see the communications, active communications between chains through the IBC protocol. Which is amazing. And there's Osmosis Central in that world, followed by Cosmos and Axelar. For instance, Axelar and Osmosis. They're doing the most activity in between. I think the most activity takes place between Osmosis and Axelar, because Axelar is a bridge to Ethereum, which brings in liquidity to Osmosis, where DeFi takes place, right? So they need each other, obviously, and there's so much connection between them. I think these kind of patterns also will emerge in Avalanche world.
Osmosis will deploy an outpost on Avalanche through Landslide, so that will be super interesting. So it will be one
totally.
under. So that's Map of Zones will start. Yeah, it's weird, right? So Map of Zones will sort of add another node inside of Avalanche, and as IBC kind of evolves into Ripple, into Near, into Solana, the Map of Zones will kind of bleed into other things a bit.
Totally, and that's something I want to also touch on a little bit, like. So like in the Cosmos world, for instance, if I open this little analysis bar on the right, so I'll first turn off this clustering thing. Let's look at the chains ordered by the number of validators they have. I mean, as you may know, in the Cosmos world, chains have limit to because of the practical Byzantine fault tolerance, up to 150 or 150 around that range. It's because they have to communicate. All of the nodes have to communicate with each other.
Yeah, it's all to all.
And it's end to end. It's really complicated messaging-wise, and brings load to every node in the network, basically.
Yep, that's why there's only 175 validators in Cosmos.
Exactly, and this list you see here, like I'll just make it. It's a long tail. It feels like a long tail, but it's really not. It's like you see, it's a long tail, but it's capped around 150. You know, as you can see, the numbers on the right-hand side, they are the number of validators per chain. You know, that's that. And then the other thing that's interesting here, and this is the kind of obvious information that some people who knows Cosmos world are familiar with this information already. But the other thing is interesting for me, the validators by number of chains. These validators are actual businesses, entities, you know, maybe individuals, but probably businesses, like services providing validation, for instance. Cosmos Station, as an example, is in the 46, almost all of them, you know, they're in all Cosmos chains. They're validating. They have a huge stake in that, obviously, ecosystem. And followed by Stake Lab, also very big. 42 different chains. They're active. Forbo, Citadel, Imperator, Figment.
This is amazing. Would you drop me this link so I can give it to our viewers?
Of course. Yeah. A long time ago, I think this data was shared by Sunny of Osmosis, I think, and I get it from there later on, and then we combine the data to build this graph. But yeah, as I said, we'll have an update version of this. I can still share this for like archival exploration. So yeah, see, this is interesting. Like there are these validators. Some of them have really huge powers. They're embedded in this network, and obviously, you know, they also provide tools and data APIs and so on and so forth. They're really part of the ecosystem. In the same way, I think in Avalanche, we'll see more validators becoming active, like being, you know, running multiple subnets, but also provide tools and data and different services, maybe like marketing, even like mechanisms. I think these are kind of mentioned in the previous talks. I remember in the earlier in the conference. So that's really good. And one thing that's interesting here also is that I think there are two important questions for me. Like as these obviously actors get more active in multiple chains, they will be also powerful, right? They will start aggregating or accruing power towards themselves because they're active in multiple chains. Of course, stakes matter. How much they stake in each chain matters, but still, they will be like, you know, quite active, especially when a governance enabled. It will be more clear, and then so it's important to keep track of the centrality in this multi-chain world. That's what I'm trying to say. Only, you know, okay, that we have to be more critical about this, and we have to be clearly following these metrics. You know, this number of connections per validator in a multi-chain world. And then the second thing is, I think this is about security sharing or security. Yeah, maybe. It's called usually mesh security in the Cosmos world.
Yeah,
I think similar things may be useful in the Avalanche world. Just to go back to the diagram a little bit, like this diagram, you know, we have these different subnets who share their nodes, validator nodes, and today the Avalanche warp messaging happens through, you know, the P chain lookup. If you remember this maybe diagram from Patrick shared some. Yeah, when they announced the project, the feature, the cross subnet messaging takes place between two subnets. But when there's a message comes in, and subnet B has to check up from the primary network whether there's enough, you know, that those validators actually sign, and that's bigger than a threshold that you have basically. And those are like two checks kind of exist there, and this is good. I think it's working well. We haven't seen it in production yet, but I think it's coming. It's about toolkits as well. But I have a question here. Like I've been asking this myself and also the team sometimes. But you know, if two subnets share a high number of validators between them, you know, with some percentage, let's say 50%, 60% or something. And then is there a need for a lookup to P chain, for every message? I think this is more like an infrastructure question for future, obviously for future subnets when there are many activities, high traffic on them. And I feel like these kind of architectural decisions will be important for the subnet architecture.
So you're asking if step 4 here, the BLS pub keys lookup can be cached?
For instance, cached, or actually because subnet A and subnet B share already the same validators to a certain percentage, they're not completely separate entities. If they share it, this allows a possibility, a potential actually to optimize the system, obviously, for security.
Yeah.
And I think this can be something considered maybe in the architectural design of the later on for the messaging, cross messaging.
Well, yeah, there's a lot in common between Avalanche Warp Messaging and IBC, right? It's a very similar concept. So I suspect that whatever mesh security sort of develops into on Cosmos, we'll see that start to develop here.
Yeah, of course there are they're similar, but at the same time a lot of differences, as you know very well. You're implementing that. Is that I like this overlapping network architecture a lot in Avalanche, which is explicitly decided from the beginning. In Cosmos, this is a bit more implicit. It's because entities share somehow. They are the same entities running multiple chains. There's no even identity system, so it's very hard to find whether that's the same entity running the other chain. And whereas in Avalanche, it's clear from the beginning. It was a decision. I think it's a very good decision.
Agreed.
In many ways, economically, but also security-wise, and communication-wise, and scaling-wise, etc. So yeah, that's the main difference. Maybe I should say in terms of platform architecture. But then there's a potential there. That's the only thing I want to say, is that you can use this to optimize further the communication. I think it's not easy, but yeah, that's possible. So yeah, I think overall these are things I want to say. And the graphs that I showed are all public. This stuff we can share the links everywhere, and on Twitter, YouTube description, or somewhere else.
Oh sure, yeah. If there's a public one. I just shared the graphcommons.com, but if there's another link.
Oh, I can, let me give the links to you right here. Where should I'll just send you our private chat there.
Great. All right, okay, so people can log into it and see it?
These are public.
Okay,
they can just click on the links and open them. It's hard. It may be hard to find them on GraphCommons directly. They have to search it. But if you share these links directly on,
we'll include it in the show notes too.
Yeah, exactly. Yeah. And Valtz.io, there's a Valtz.io has also obviously the stuff there too. Not the Cosmos, but the other ones. That's more or less what I want to say.
Great.
So we're currently working on a better version of the up-to-date version of Cosmos, and automatic updates for the entire graph, so that we can anytime check this out and then see the use like a dashboard, a network monitor for the entire network. Yeah.
Great. Amazing. What else would you like to dive in a little more here, or would you like to sort of pivot the conversation into something else you'd like to discuss?
I think overall, I'm looking forward to really use the Avalanche, the new SDK, Hyper SDK, and also I want to try these Cosmos bridge with Avalanche, and I mean, I'm more or less, that's what I want to say.
Oh, right on. Well, we just opened
maybe if there are questions or something.
Yeah, if there are questions on Twitter, please throw up a hand and we'll bring you on stage. Otherwise, it doesn't look like we have any. So, happy to. Well, we just open sourced our one of our core repos. So we're gonna open an incentivized testnet soon. So people can play around with it and see what that looks like. So that's cool. Yeah. I don't have any other questions. This was great. I actually, you answered
Do
a ton
you
of my
do you
questions.
plan to have a native staking token on your
Yeah,
subnet?
yeah,
Right.
absolutely.
Yeah.
I think it will be necessary as like, you know, in like a year from now when things get really heavy from like coming from IBC. I suspect there might be multiple versions of Landslide as a subnet. Like that's kind of the future thing, but initially, yeah, I think we should be able to handle the volume. Like we should probably integrate with Hyper, right? I mean, we're running a WASM based virtual machine. So
Okay.
there are some tweaks we can make to it.
That's a
And
Rust implementation, right?
yeah.
Yeah, okay, cool.
Yeah. So there's, as things develop, our IBC implementation basically opens, like we're going to open source the light client in about 4 months. We're working with the Strangelove team and the ICF, the Interchain Foundation, to bring that out. So so
Maybe
initially it'll be. Go ahead.
No. I was gonna say. I mean, when you say ICF, it just immediately reminds me the Atom 2.0 paper. I remember that. I read it. It's amazing. This concept of turning the Cosmos Hub into MEV, like a auction house or something, or clearing house, something like that. For the Cosmos ecosystem. It's a great idea because their chain-to-chain connections. There's always MEV opportunity there. Both chains, like the cross-chain arbitrage stuff.
Yeah. We're talking to Skip protocol about that. Those guys.
Oh yeah.
Yeah. So Osmosis natively implements Skip to basically eat the MEV opportunities and send it back to the token holders.
I wonder what you think about that, because that opportunity will exist when you have the bridge between Avalanche and Cosmos too.
Yeah. Oh yeah, totally. Oh yeah, I think
ecosystem.
Well, I think there are two. There are either two directions, right? You either take the osmosis approach, which is the Robinhood sort of approach, right, where you take it and you give it to the token holders, or you build one that doesn't have that, and it's just like you have to build a sort of a dark pool where it prevents it, like an implementation of what happens in Enclave, right? Avalabs built Enclave.markets as a MEV prevention place. So it's kind of one of those
private transaction.
Exactly.
Or private, through the mempool privatization, or no, private encrypted mempool, so that you have basically, that's cool. I think. And that's something to discuss. I think in general for like MEV type of discussion is important for obviously cross-chain and cross-subnet.
Yeah, we should do a Twitter space with the Skip team and have you on it.
Yeah. I think exactly. Also, Sam Hart from Skip is a good friend of mine. We can always bring him in. Maybe
sure.
The person to discuss these things. I think very good. Yeah, cool.
All right, man. Well, we can keep it short if you want. You answered all my questions. I think it's great.
Yeah, it was a short because maps easy to understand. Like you dive in and you get it.
Cool.
So there are a lot of tools out there in the Graph Commons for mapping and analysis of these kind of maps and blockchains. Those are like you can try it yourself. That's what it is, like self-serve analytics tool. So these are open, explorable graphs for everyone. Yeah.
Great. All right, Barak. Well, thank you so much for your time. I appreciate it. I'll also include your bio and all the links to your artwork as well in the show notes. So thank you so much for your time. We look forward to seeing you in the space.
Yeah, thank you.
Thank you.
Bye-bye.
All right.